What is the energy in joules required to shift the electron of the hydrogen atom from first Bohr orbit to the fifth Bohr orbit? Now, NCERT is absolutely in love with fifth orbit for some strange reason. And what is the wavelength of the light emitted when the electron returns to the ground state? Okay, the ground state electron energy is so much. That's not very problematic. First Bohr to fifth Bohr orbit. So you have n is equal to 1, lovely. And from there, you are uplifting the electron to n is equal to 5. So you have to supply energy. How much energy? There is some energy in the first orbit, E naught. And energy in fifth orbit is E naught z square by n square, which is E naught by 25. So the difference in energy, delta E is equal to energy supplied to the electron. In which process? In the process of moving it from 1 to 5. And that would be E5 minus E naught. E5 is E naught by 25 minus E naught, which is 24 by 25 times, minus 24 by 25 times E naught. And how much is E naught? I am given E naught. This is minus 24 by 25 times. E naught is again minus, so minus becomes plus 2.18 into 10 raised to minus 11 ergs. That's not very difficult. Ergs to joules is a straightforward journey. You know the conversion. So you calculate this. This comes out to be 2.093. A little less than 2.18 into 10 raised to minus 11 ergs, which is 2.093 into 10 raised to minus 18 joules. Oh my God, I'm sorry. It's a little ugly, but yeah. This is the answer? Yes, this is the answer. This is the energy that is required. Don't forget, 1 erg is 10 raised to minus 7 joules. This is the conversion we have used, and this is the answer we get. That's the first part. We have used this energy to push it up. And if it falls back, it is going to emit a photon, and the photon also would have exactly the same energy, right? So what about, and they've asked, what is the wavelength of light emitted? So let us find the wavelength of light. Now, energy of photon, we know this is 2.093 into 10 raised to minus 18 joules. We just calculated whatever energy is absorbed from 1 to 5, the same energy will be emitted from 5 to 1 if you go back. This is energy of photon emitted, which will be equal to hc by lambda. The lovely lambda is h 6.626 into 10 raised to minus 34 joule second into 3 into 10 raised to 8 meters per second divided by 2.093 into 10 raised to minus 18 joules. Fascinating. Let's solve this out. How much does that give me? This is 6.626 into 3 by 2.093, all fanciful numbers, into 10 raised to how much? This is 18 plus 8, 26, 26 and 34, that is 10 raised to minus 8 into 10 raised to minus 8 meters. 10 raised to minus 8 meter is as good as 10 raised to minus 6 centimeter. And you have to solve this. 6 is 18, this is 19 point something by 2, 9.51. So the answer comes out to be 9.51 into 10 to minus 6 centimeter on solving.